Good morning, students. Welcome to Punajandra Higher Secondary School. So, we were continuing our chapter number 3, that is motion in a straight line. In the previous class, we are discussing about the distance, displacement, the difference between distance and displacement, then speed. In the speed, we have discussed average speed, instantaneous speed. This thing we have discussed in our previous class or in my previous videos. So, by continuing this session, in this video lecture, let us discuss about the velocity. Okay. So now, first of all, we define the velocity. Speed and velocity both are only one sense they are different. In case of speed, the speed is a scalar quantity. It does not depend upon the direction of the object. Okay, but the velocity is a vector quantity which must depend upon the direction of the object. So that's why the velocity can be defined as, listen very carefully, velocity can be defined as the rate of change of displacement. The rate of change of displacement in a particular direction. That is a very important point. Okay, so rate of change of displacement means the change of the displacement with respect to time gives me the rate of change of displacement. Okay, and in a particular direction, because velocity is a vector quantity. So mathematically what I can write? So velocity, let us denote it as v, very simple. So v is equal to, that is the rate of change of the displacement. Suppose I can take the displacement as x. Okay, so rate of change of displacement I can write down, that is dx divided by dt. Dx divided by dt. So this is the rate of change of the displacement, or simply, so this is actually better I can write not dx by dt, better I can write change of displacement with respect to time. This is the better way to represent. So d is equal to del x divided by del t. This is nothing but your velocity. That is change of displacement with respect to time. That is x2 minus x1 divided by t2 minus t1. This is nothing but where, remember, this x represent the displacement. This is a very important point. Okay, not a distance. What happens in the previous class? In the previous class, in the speed portion, what I have discussed, the speed is the rate of change of the distance of the object. The rate of change of distance of the object gives me the speed of the object, and it is a scalar quantity. It does not depend upon the direction of the object, in which direction the object will move. But in this case, the velocity is a vector quantity. So that's why we are not taking the distance, we are taking the displacement. Clear? So v is equal to x2 minus divided by t2 minus t1. Clear all of you? So this is the concept of your velocity, that is rate of change of displacement with respect to time or in a particular direction. Clear? The next year, average velocity. Average velocity. Okay, so let us discuss about the average velocity. What happens in the average speed? Because these are equivalent terms, so we have to compare these two. So what happens in the average speed? Average speed is the total distance covered by the object divided by the total time taken by the object. Okay, so in the similar way, average velocity is the total displacement. The total displacement covered by the object in a particular direction divided by the total time taken. So that's the average velocity. So VAVZ, I can write this is VAVZ. Okay, average velocity is equal to total displacement covered divided by total time taken. Clear? So this is your average velocity. And again it is in a particular direction because velocity is a vector quantity. Clear all of you? In the next part I have to solve a problem, so don't worry about that one. So velocity, this is now the average velocity. Okay? So now the next after finding out the average velocity, let us discuss about the instantaneous velocity. Instantaneous velocity. Okay? So instantaneous means at a particular instant of time. It's very simple. Suppose we are moving in a bike. Very simple. We are moving in a bike and there is a speedometer above it or in front of us. Okay. So when I will move the accelerator more, then the speedometer shows more deflections. But suppose I want to know at a particular instant of time. Suppose at 10 am. Suppose at 10 am what is the speed? Then I can easily find out at this moment I can, and at that same moment what is the speed that gives me the instantaneous velocity of that bike. Clear all of you? So that means the velocity of the object at a particular instant of time gives me instantaneous velocity. At a particular instant, at a particular time period, at t is equal to this, at t is equal to suppose 10 minutes, at t is equal to 5 minutes, at t is equal to 2 minutes. So at a particular instant of time, whatever the velocity of the object, that velocity is nothing but your instantaneous velocity of that object at the particular instant. Understood? So instantaneous velocity mathematically how it can represent? As we represent the instantaneous speed, so the instantaneous velocity can also be represented in this way. Look at very carefully. So that means I must have to take the limit. So limit, the time period must be tends to 0, limit tends to 0, del x divided by del t. So which is nothing but your, according to the mathematics, that is dx by dt. So instantaneous velocity mathematical expression becomes dx divided by dt. So by using this expression dx divided by dt, that is the change of, look at here, that is the change of displacement with respect to the time. Okay, or it is otherwise mathematically called derivative with respect to time. Derivative of what? The derivative of displacement dx by dt. Okay, so that is the derivative of displacement with respect to time gives me the instantaneous velocity of that object at a particular instant of time. Clear? So this is the mathematical expression. So velocity, average velocity, then your instantaneous velocity. These are the three important points. Clear? So now let us solve a problem. Now you can very easily clear how the instantaneous average can be found out. So let us solve a problem. Suppose, look at the problem very carefully, then you can easily rectify, easily know. So this is your, suppose this is your number line. In the number line, so this is your x-axis. Okay, this is your x-axis. This is your minus x-axis. Clear all of you? Then I have to take in the x-axis what? Now what is the kilometer covered? Clear? So let us take it. So this is 10, 20, 30, 40, 50, 60, 70, 80. Suppose I take. Okay. This I can take minus 10, minus 20, minus 30, minus 40, minus 50 and so on. Okay. Now suppose a object is starting from the at this station. So at t is equal to 0, the object is at A. Look at very carefully. At t is equal to 0. This is at t is equal to 0. That means at this time the object is at rest. Okay. So t is equal to 0. It is starting from here. Clear? Okay. So now because the object not starting from the origin, it's starting from here 20 mm. Clear all of you? Now the object is going to the position B through C. Again I will repeat. The object starts from A, going towards B, and again return back to C. Again return back to C. Clear all of you? The object going to B, towards B, and again it will return to C. So this is my question. So what is the path? Let us find out. So this is the question. So what the question is? The question is at t is equal to 0. Listen very carefully. At t is equal to 0. At t is equal to 0. The object is at A. The object is at A. Then it will go towards C, towards B, and it is again coming to C. This is the path. Okay, and what we have to find out for this path? So this is my path followed. This is my path of the object. Okay, again I'll repeat. The object starts from A, going to B, through C, and again from B it will return back to C. Listen very carefully. Okay, so this is my path. That is A, C, B, again to C. Clear? And at t is equal to 0, the object is at A position. Clear? So what do you have to find out? Now I have to find out the average speed of the object, question mark, and I have to find out the average velocity of the object. These are the two things we have to going to find out. These are the two important points. What is the average speed of the object? What is the average velocity of the object? So let us find out one by one. Okay. So first find out average speed. Clear? So what is my average speed? Clear? So what is the average speed? Let us discuss. So what is average speed? The total distance covered. What is the average speed? The total distance covered. Total distance. The total distance covered divided by total time taken. Total time taken. So now the object starts from A, going to B through C, and again return back to C in how many seconds? Now in 2 seconds, suppose. Okay. So now the object starts from A, going towards B, and again return back to C in how many seconds? 2 seconds. Clear all of you? So there is mention here 2 seconds. Clear? So now that is equal to, so that means total time taken I already knew, that is 2 seconds. Clear? The total time taken is your 2 seconds. So what I have to find out? Total distance covered. So let us find out the total distance covered. So object start from A, first go to C, then B, then again return back to C. So what is this? What is this distance? Starts from 20, going to 40. Okay, so that means the distance is 20. Clear? Then again 40, then 280. So this is 40. So 20 plus 40. 20 plus 40. How much? 60. Clear? Then again it will return back to here. Again it will return back the position to C. So return back means what is the distance covered? Again 40. So what is the total distance covered? The total distance covered is 20 plus 40 plus 40. That is nothing but your 100. Clear all of you? Clear? Again I will repeat. The object starts from A, not from origin. Again I will repeat. The object do not starts from origin. The object starts from A. First go to C. That means the distance covered is 20 km. Then C to B is 40 km. So 20 plus 40 is 60. Then again from B to C is again 40 km. So 20 plus 40 plus 40. How much? 100 km. Clear all of you? So that is nothing but your 50 km per. So this is your, suppose this is second, not actually this is I have to take suppose hour, 2 hour better, because this is kilometer I have taken, so let us take it 2 hour. Okay, so this is kilometer per hour. Understood? Okay. So now the path is from A to C, C to B, B to C. In how many? The time interval in 2 hours. So average speed is equal to total distance covered divided by total time taken. So total distance covered, I have already distance is 100 km. 20. This is 20. This is 40. And again return back is 40. So 20 plus 40 plus 40. Nothing but your 100. Clear all of you? So this is your average speed. And I have already told you that speed is a scalar quantity. So that's why the direction doesn't matter. Okay, so that's why the value always positive one. Now come to the second part. That is your average velocity. Look at very carefully how the average velocity. So average velocity, what is the formula? The total displacement divided by total time. The formula is total displacement divided by total time. Very simple. So let us find out from A to C to B and again to C. So what is the total displacement? Let us find out. Total. What is displacement? Displacement is nothing but the shortest path. The shortest path between the initial position and the final position. Very simple. So that means in initial the object starts from A and end the journey in C. So what is my shortest path? The shortest path is from A to C. Very simple. The shortest path is from A to C. Clear all of you? So that's why what you have to find out. I have to total distance covered. Sorry, total displacement. Total displacement. So let us find out. So it starts from A, ending in here. Okay. So that is nothing but so this is your 20. Clear all of you? So 20 kilometer divided by 2. Okay. So this is your 10 kilometer. And very interestingly, this is the positive value plus, because I have to taken into consideration here the sign, not here, because it is a scalar quantity, but velocity is a vector quantity. So that's why I have to take into consideration the positive value. Understood all of you? So that's why it starts from A, going to B and return back to C. So that's why the shortest path is 40 minus 20, that is your 20 plus 20. Clear? Okay. So 20 km divided by 2, then 10 km plus 10. What is the significance of plus 10 km? The significance of plus 10 km is the object is moving in positive x direction. This is the positive x direction. Understood? So the average velocity is plus 10 km per hour in which direction? Positive x direction. Because plus x direction, because it is positive here. Understood all of you? So that's why in case of average speed, we do not consider the sign or the direction, but in case of average velocity, we must have to consider the direction of the sign. Understood? This is a very, very important concept. Clear? Okay. Then now, so this is how we can calculate, very simple, this is how we can calculate the average speed and average velocity. I think all of you clear how to calculate the average speed and average velocity from this. Understood? All of you clear? Okay? Okay. Now, take another example, that is instantaneous velocity. Let us take an example, because instantaneous velocity V instantaneous is equal to how much? Dx divided by dt. So let us solve a problem from it. How we will calculate the instantaneous velocity? Look at very carefully. Suppose a question is there, a object or a body is traveling with a displacement x, which is a function of time. So x is equal to how much? now 5t square plus 3t plus 2. Clear all of you? Again I will repeat, what is the question? The question is, a body or an object travel in a straight line, okay, having a displacement which is a function of time. So the displacement is represented in this manner. Okay, so x is the displacement. And which type of displacement? The variable displacement, because the displacement here not constant. The displacement x depend upon the time value. Clear all of you? So the displacement x is directly proportional to the time value. As the time changes, the displacement changes. Clear? So that's why the displacement x is represented as 5t square plus 3t plus 2. Clear? So now what is our aim? Now our aim to find out, again I will repeat, to find out the velocity of the object at time period t is equal to 3 seconds. Clear? So that's why what is our aim? Now our aim to find out the velocity of the object at which time interval? That t is equal to 3 seconds. Clear? So the displacement, again I will repeat, displacement is a function of time, so that's why x is equal to this much. So let us find out the velocity. So we know that velocity v is equal to dx by dt. So v is equal to dx divided by dt, and it is nothing but the derivative of x with respect to time. Again I will repeat, derivative of x with respect to time period. So how to solve this type of function? Listen very carefully. So d by, this is the formula. This is the formula, mathematical to the formula. So this is your d by dt, t to the power n. Okay, so the formula becomes n t to the power n minus 1. Okay, so this is my formula, that is n t to the power n minus 1. So now let us put this formula here. Okay, so d by dt, so let us, the 5 is a constant, let us take it outside. So d by dt, so this is 2 n t to the power n minus 1, so 2 t to the power 2 minus 1. Look at very carefully. Okay, plus, then 3 is a constant, so let us take it outside. So d by dt, so t to the power, the power is 1, so this is becomes 1 minus 1. Clear? And the last term, the derivative of a constant becomes 0. Clear? So that is equal to, so now these two I am putting it outside. So what is the value? The 10. 5 into 2 is your 10. Clear? And d by over, so 5 into 2 is your 10, and this is your t, 2 is your 2 minus 1. Clear? So now derivative we have already find out. The derivative we have already find out. Clear? So 10 t to the power 2 minus 1 means 10 t to the power 1 plus this is 3 t to the power 0, and this is 0. So 10 t plus 3, this much. Clear? Because t to the power 0 is 1. So what is the velocity I will get? Now v is equal to 10t plus 3. Okay, so now this is my final expression after finding out the derivative. So v is equal to 10t plus 3. Now what is our aim? Now we have to find out the velocity. T is equal to 3 seconds. So let us, so at t is equal to 3 seconds, so v is equal to, so 10 into 3 plus 3, so that is your 30 plus 3, so that is your 33. Suppose this is in meter, so this is your 33 meter per second. Understood all of you? So in this way you can calculate, the value of instantaneous velocity. So look at here, this is your, the final calculated value of velocity is nothing but your instantaneous velocity, because at t is equal to 3 seconds, particular at this instant of time, what is my velocity? Now v is equal to 33 meter per second. Clear? So this gives my instantaneous velocity. Understood all of you? So these are these type of problems. Can we solve the previous one? How to calculate the average speed, average velocity, and this is how we can calculate the instantaneous velocity of an object. Clear? Clear all of you? Then come to the next part, that is your acceleration. Next is your acceleration. Okay. Next is your acceleration, which is a very important physical quantity. So what is acceleration? Let us denote it as A. Acceleration. So what is acceleration? Let us first discuss. So acceleration involved in a body when the body is not in a constant velocity. Listen very carefully. If the body is in a varying velocity, the velocity is not constant over a time period, it will vary, then this term arises, acceleration. Clear? Again I will repeat the term. When an object is varying with the velocity, with respect to time, then acceleration term arises. Okay, so acceleration is nothing but the rate of change of velocity. The rate of change of velocity in a particular direction, because acceleration is a vector quantity. Clear all of you? Okay, so acceleration is nothing but the change of velocity of an object with respect to time in a particular direction. So now simply I can write the acceleration A is equal to, so rate of change of, so that is del V divided by del T, the change of velocity with respect to time, del V divided by del T, and it is a vector quantity. It depends upon the direction. It depends upon the direction of the object in which the velocity or in which the object is moving. Okay, so A is equal to del V by del T. This is the expression of your acceleration. Okay, so now with this, now if we will find out the what do you call average acceleration. So average acceleration is very simple. Suppose a body is having number of velocity in a subsequent time interval, then simply the average velocity. Let us take an example. Suppose an object is having an acceleration, suppose what you can call, suppose an acceleration, your A is equal to d divided t. So now the velocity becomes, suppose v1 at a time t1, an object is velocity v2 at a time t2. Suppose the object having velocity v3 at a time t3. Clear? So if an object is velocity v1 at a time t1, the object is having a velocity at a time t2, the velocity becomes v2, and the velocity becomes v3 at time t3. Then how to find out the average velocity? How to find out the v, your A, B, C, because average acceleration. So average acceleration is nothing but the total velocity, v1 plus v2 plus v3 divided by total time taken, t1 plus t2 plus t3. Total velocity by total time gives me the average velocity. Very simple. Clear? Okay, so this is my average, your average acceleration. Sorry, gives me the average acceleration of an object. Okay, so now if I will go to the instantaneous acceleration, if I will go to the next is your instantaneous acceleration. So instantaneous acceleration, so how can calculate in the same way? That is the acceleration of any object or a body at a particular instant of time. Okay, so the mathematically represent limit in the same way. That time period tends to 0, limit del t tends to 0, del v by del t, mathematically which is nothing but dv by dt. So this is the expression of your instantaneous acceleration. So limit, the time period must be time period goes to infinite means the time period have to concentrate on a particular time period. So that's why del t is limit or del t tends to 0. Clear? So that is del v by del t, which gives me the dv by dt, which is a formula you can take as a formula. So dv by dt is nothing but the instantaneous acceleration or the acceleration of an object at a particular instant of time. And from this part, in the similar way, I can solve some problems. Look at here. Suppose a object is having a velocity. Look at very carefully. Suppose a object is having a velocity which is a function of time. Again, I will repeat, which is a function of time. V is equal to the same manner. Suppose 10 t square plus 5t plus 3 meter per second. So the velocity of an object which is not a constant velocity, which is a varying velocity, because the velocity depends upon the time, is represented in this manner. V is a function of time, so V is equal to 10t square plus 5t plus 3 meter per second. Okay, this is given. This is given. So what we are going to find out? Now we are going to find out the acceleration. Acceleration. Which type of acceleration? The instantaneous acceleration. Acceleration we are going to find out at time is equal to, suppose, 5 seconds. How much? 5 seconds. I have to find out the acceleration of that object at 5 seconds. Okay, so let us find out. So there, acceleration A, the formula is instantaneous acceleration dv by dt. So that is equal to, so the same formula I have to use. What is the formula? Just I have discussed that formula. D by dt, t to the power n. The formula is n, t to the power n minus 1. This is my formula. I have to apply this formula here. So now dv by dt. So 10 t square plus 5t plus d by dt. So that is equal to d by dt 10t square, d by dt 5t, d by dt 3. So that is equal to, now what I can take? So this is 10, I have to take outside. So 10 into d by dt t square, I have to apply this formula. So 2t to the power 2 minus 1. So this is 2 t to the power 2 minus 1, that means 1. Okay, plus this one, so take it outside 5 d by dt t. So d by dt t means t to the power 0, and rest the last one, the derivative of a constant. This is a constant now, 3 is a constant, so derivative of a constant becomes 0. So that is equal to, so this is a 10 into 2 gives me 20. So 20t plus 5. Clear? 20t plus 5. So this is my acceleration expression. Which type of acceleration? The instantaneous acceleration, which is a function of time. But we have to find out the acceleration at a particular instant at 5 seconds. So let us find out. At t is equal to 5 seconds is equal to a is equal to 20 into 5 plus 5. So 20 into 5 is your 100 plus 5. So this is your 105. Clear? 105 meter per second square. Clear? So now remember, acceleration is, so in this way you can solve problems from instant. This value, this acceleration value gives me which type of acceleration? The instantaneous acceleration, that is the instantaneous acceleration at a particular instant of time. Here I have to take t is equal to 5 seconds. Understood all of you? Clear? So now acceleration. So 3. What are the units? Let us summarize. Let us summarize one by one in this chapter. So distance unit is, SI unit is meter. Distance SI unit is meter. Okay. And your dimensional formula is m0, l1, t0. Okay. And it is a scalar quantity. It is a scalar quantity. Then come to your displacement. It is a vector quantity because it depends upon the magnitude, so also the direction. It is also having a unit meter, and it is also having a dimension m0, l1, t0. Understood? Then come to your speed, which is a scalar quantity. Unit is meter per second, and this is your m0, l1, t to the power minus 1. Then come to your velocity. So velocity is a vector quantity. The unit again same, meter per second, m0, l1, t to the power minus 1. Then come to the acceleration. Okay, it is again a vector quantity. Unit is meter per second square, and your dimension is m0, l1, t to the power minus 2. So this thing we have discussed till now, the problems we have solved. Understood, all of you? So in the next class we are going to derive the equations relating these velocity, acceleration and time period. These are the equation of motion. In the next class we will derive how we will derive graphically, okay, and so also in calculus method. In the next class we will derive. Thank you. Have a good